Hey guys, welcome back to Math by Saba. Today we're going to talk about solving quadratic equations. Before we start, do not forget to subscribe to my channel and press the like button. Thank you. Um, as we mentioned before when we were talking about quadratic functions, we said that a quadratic equation can have two real roots, one real root, or no real roots. When we are solving a quadratic function, we want to find its roots. Sometimes for finding a quadratic equation roots, we need to use identities. Identities are some expression that are always true for any amount. Based on our calculation, we used to choose what side of this equation. When we are having multiplication of some factors equal to 0, it means A is equal to 0, or B is equal to 0, or C is equal to 0. When we have a quadratic equation, we can write it as two linear factors. So we can modify a quadratic equation into two linear equations. Solving two linear equations is always easier than solving a quadratic equation. That's why we use identities to simplify or modify a quadratic equation into multiple or two quadratic linear equations. The first identity that we want to learn how to use is perfect squares. As you can see here, we have a linear function to the power of 2, a linear expression to the power of 2. We can write it as in the general way by just multiplying these two factors together. Okay, we can use the FOIL method. What was the FOIL method? First, outers, inners, lasts. I'm gonna first multiply the first factors, x to the power of 2, outers, xa plus xa, inners again plus xa, and lasts that are a and a, which is a to the power of 2. If you simplify it by adding the like terms, which are xa's, you'll get to x to the power of 2 plus 2xa plus a to the power of 2, which is the same as the right side of our equation. So this is basically just getting to the answer faster. By memorizing the perfect square identity, you get to the answer faster. It's important to have its shape in our mind because sometimes we should figure out that we have to use perfect square by looking at the face of the problem. We have the same for subtraction, but we have to be careful. Whenever we have an addition in our parentheses, we have an addition here. Whenever we have subtraction here, we have a minus here. So when you get familiar with the face and appearance of the perfect square identity, it's time for you to solve an example. Look at here. We want to solve this equation using perfect square identities. X to the power of 2 minus 6x plus 9 equal to 0. First of all, you have to make sure that the coefficient of x to the power of 2 is always 1 or -1, or you can make it 1. I'm going to show you how in next examples. Then second step is to check the constant term. The constant term should always be a perfect square. We all know that 9 is a perfect square, which is 3 to the power of 2. So from that, we know that our second factor, aka a in this identity, is 3 here. When we figure out the coefficient of x and make sure that it's 1. And when we figure out the amount of a, we should check if the middle term makes negative 2ax. In this case, negative 2ax because 6 has the negative sign. Whenever we have a negative sign, we go for the second uh, case of our perfect square identity. Let's see whether our negative 6x is negative 2a. Okay, negative 2 minus 3 is negative 6, so we're good to go. So we can write x minus a to the power of 2. We had this side of our identity. We wanted to modify it to the left side of our identity. What is x is x? What is our a here? A is 3. So I'm going to substitute x minus 3 to the power of 2. Now the only thing to do is to solve this equation. We make a radical to the both side of our equation. Then what is left? X minus 3 is equal to 0. And then x equal to 3. So our quadratic equation had only one real root here. Okay, let's do another example. Here is a positive, so I'm gonna guess that the one that we're using here is this one, x to the power of 2 plus 2ax plus a to the power of 2. We have this side. We want to make this side. Okay, let's go. Let me compare these two expressions. First of all, we want to make sure that the coefficient of x is 1. It is 1. We are good to go. A to the power of 2 is equal to 4. So a is 2. Let me check the middle term. The middle term, 2 times a should make 4, so we can use this identity. 2 times 2 is 4, so we're good to go. I can write this equation as x plus 2 to the power of 2. Instead of this equation, I have this equal to 0. Let's radical out both sides. What do we have next? X plus 2 is equal to 0, so x is equal to negative 2. In all of the equations that can be solved using perfect square, you can be sure that you many of the times, usually you have one root. You have only one real root. When you don't have a clean quadratic equation, you have to make it clean. For example, here, first you have to move all the terms to the left side and make the right side 0 and then try to solve it. X plus 2 minus 14x plus 30 plus 2x plus 6 is equal to 0. Because I'm transferring these terms to the other side, all the minuses are becoming pluses. Okay, let's simplify like terms together. These two are like terms. These two are like terms. Okay, x to the power of 2 minus 14 plus 2 is negative 12x plus 3 plus 6 is plus 36 is equal to 0. Now it's your turn to solve this last example. Let me know in the comments what's your answer. Thank you guys for watching me. See you next time.